Hello everyone. Today's session we are going to see Unit 7 Dual Nature of Radiation and Matter Solution to Book Back MCQs. Photons of wavelength lambda are incident on a metal. The most energetic electrons ejected from the metal are bent into a circular arc of radius r due to perpendicular magnetic field having magnitude b. What is the work function of the metal? The solution is Einstein's photoelectric equation is h mu is equal to phi naught plus half mv square. We need to find what is the work function. So you can write work function phi naught is equal to h mu minus half mv square. Here in the options we have here hc by lambda throughout. So we don't want to disturb this term. So we have phi naught is equal to h into, since we know C is equal to mu lambda and mu is equal to C by lambda. We put here instead of mu it is C by lambda minus half mv square. Here we have to find what is that velocity. Since it is the mass of the electron, we can write here to be me. We need to find here velocity v square. Once again we see the question. The most energetic electrons are bent into a circular arc by the magnetic field having a magnitude b. So because of that magnetic field, these electrons are bent in the form of circular arc. The force due to the magnetic field F is equal to BeV. And the centripetal force we know F is equal to mv square by r. We shall equate both the forces. Therefore, we have here mv square by r is equal to BeV. And here one v and other v will be getting cancelled. Remaining we have v is equal to be. This r goes to the numerator divided by m. Since we need v square, so we write here v square is equal to, it is be r divided by m the whole square. Let me write here me. We need to find what is the work function. And we substitute the value of v square here. Therefore, we have phi naught is equal to hc by lambda minus half me into ber divided by me the whole square. For our convenience, we shall multiply this term alone by 2 and divide by 2. Therefore, we have this phi naught is equal to hc by lambda minus 2me into, it is ber divided by me the whole square, and here it is 4. So 2 2s are 4 will be there. If I wish to take this 4 inside the bracket, then I can write that to be phi naught is equal to hc by lambda minus 2me into ber divided by this 4. If I take here, it becomes 2me the whole square. So 2 the whole square means it is 4. So this is that solution we are getting. Phi naught is equal to hc by lambda minus 2me into ber E R divided by 2 me the whole square. We have option D to be the correct one. So this is a work function of the metal. The work function for metal A, B and C are 1.92 electrovolt, 2 electrovolt and 5 electrovolt respectively. The metals which will emit photoelectrons for a radiation of wavelength 4100 angstrom is asked. The solution is, for the emission of photoelectrons, the energy of each incident photon must be greater than or equal to the work function of the metal surface. Here we have to find the energy. Given the wavelength is 4100 angstrom, the energy E is equal to h mu. And again, since C is equal to mu lambda, mu is equal to C by lambda. Therefore, we have the energy E is equal to H into C by lambda. So, we write energy E is equal to H value, the Planck's constant, 6.6 into 10 power of minus 34, C 3 into 10 power of 8 divided by the wavelength 4100 angstrom, so it into 10 power of minus 10 meter. We simplify this so that we have energy is equal to 4.829 into 10 power of minus 19 joules. We shall now convert joule into electrovolt. So we write 1 electrovolt is equal to 1.6 into 10 power of minus 19 joule. Joule to electrovolt, 1 joule is equal to 1 divided by 1.6 into 10 power of minus 19 electrovolt. Therefore, we have E is equal to 4.829 into 10 power of minus 19 divided by 1.6 into 10 power of minus 19. Here we have the energy is equal to 3.018 electrovolt. We have seen that the energy of the incident photon, that is, for emission of photoelectrons, the energy of the incident photon must be greater than the work function phi naught. So this is that energy value now. We have to see it for the work function of each metal. For metal A, it's given in the question, the work function is 1.92 electrovolt. We have the energy is equal to 3.018 electrovolt. So we say that here the energy is greater than the work function phi naught. Therefore, we can say that the metal A will emit photoelectron. Next one, for metal B, given the work function is 2 electrovolt and we have the energy E is equal to 3.018 electrovolt. So here too we see that energy is greater than the work function and therefore we can say the metal B will emit photoelectrons. For metal C, the work function is 5 electrovolt as we have E is equal to 3.018 electrovolt. We see that the energy is less than the work function. So that we can say that the metal C will not emit photoelectrons. In the question, it's asked the metals which will emit the photoelectrons for a radiation of wavelength 4100 angstrom is asked. Metal A will emit photoelectron and metal B will be emitting photoelectron. Option B is the correct one, both A and B. Thank you.